Problem 5, Day 1, we're looking at solving polynomial equations. We're going to find solutions and zeros. We have used the zero product property and we call this ZPP to solve quadratic functions. You can extend this to solve some higher degree polynomial equations. So we're going to solve a polynomial equation by factoring. We have 2x cubed minus 12x squared plus 18x equals 0. So we always look for factoring a common monomial, or our GCF. So what can we divide out of all three? We can divide out a 2x. So we divide out a 2x, we are left with x squared minus 6x plus 9. Now don't forget, whatever you divide out, it goes in the front. It is really important, especially when it is a variable, because that's one of our solutions. And this equals 0. So now we solve. So we're going to factor using any learned factoring technique. So we're going to factor x squared minus x plus 9. So I'm going to just write this down here. And so let's use the x method. So it multiplies to 9, that adds to negative 6. Well, that's negative 3 and negative 3. So we can write that, and the a is 1, so we can just go ahead and factor it. So this is 2x times x minus 3 times x minus 3. We could also write that as 2x times x minus 3 squared. And again, this all equals 0. So the last thing we need to do is to use the zero product property to solve for x. So here, what that means is we just set each piece equal to 0. So 2x equals 0. And then x minus 3 equals 0. So to solve, so you divide by 2. So our first root is 0. 0 divided by 2 is 0. Then we add 3 on this right side. So we see that our other 0 is at 3. 0 and 3. So x equals 0, x equals 3. So you try, solve the equation. So see, look at the GCF if there is a GCF, and then factor. So hopefully you got this far. You divided by 4, then you would have gotten 4 times x to the 4th minus 10x squared plus 9 equals 0. So remember from the previous lesson is that when you have a higher power, this is okay. It's a quadratic form. So this 4 is twice this, or it's 2 is half of 4. So I can just cut it in half, x squared and x squared. Then I use the x method. So it multiplies to 9, that adds to 10. That's negative 1 and negative 9, so that goes here. Now look in here, x squared minus 1 and x squared minus 9. Those are both difference of two squares. So these factor even further. Both of them do. So difference of two squares, again, that's when the center is negative, and then you could square root the front term and the back term of the binomial, and you know you can factor further. So looking at the first one, x squared minus 1, the square root of x squared is x and x. Square root of 1 is just 1, and then it's plus and minus. Now let's do the x squared minus 9. So x squared, square root of x squared is just x and x. Square root of 9 is 3 and 3, so it's a positive 3 and a negative 3. So therefore, we have 4 solutions here using the zero product property. Okay, if you need this, so x plus 1 equals 0, x minus 1 equals 0, x plus 3 equals 0, and x minus 3 equals 0. Then you solve for x. So x equals 1 here. X equals negative 1 here. X equals positive 1 here. X equals negative 3, and x equals 3. So we have 4 solutions. So try this example here. You need to first set it equal to 0. So hopefully you got this far on this problem. So you subtract 14x cubed from both sides, and then make sure you write it in descending order. So 2x to the 5th minus 14x cubed plus 24x equals 0. Then I can take out a common factor, 2x divided by 2x, so 2x goes here. I'm left with x to the 4th minus 7x squared plus 12 equals 0. So I do the x method, what multiplies to 12, that adds to negative 7, negative 4, and negative 3. So the 2x gets written in the front. Now it's of a higher degree, x to the 4th. Remember, just divide that in half. So you write an x squared and an x squared. Then you put in the x squared minus 4 and then the minus 3, and that all equals 0. This factor here, x squared minus 4, that's a difference of 2 squares. So we can square root the front, square root the back, and then so that factors to x minus 2 and x plus 2, and here we are here. Now the last part is we use the zero product property to solve. And so for some of this, so this one, 2x, that's 2x equals 0. Here, this is x minus 2 equals 0. And then x plus 2 equals 0. And then this one as well, x squared minus 3 equals 0. So these first three is probably pretty fast. You know that x equals 0. You know that x equals 2. Here, x equals negative 2. And then here, so remember to solve using square root. So you add 3 to both sides. X squared equals 3. You take the square root. And then remember what happens when you take the square root. You get a plus or minus of that answer. So we have x equals plus or minus the square root of 3. Or let me rewrite that. X equals square root of 3 and x equals negative square root of 3. So we have 5 solutions. In example 3, the factor x minus 3 appears more than once. Okay, so for example, over here, remember we had x minus 3, and then it's squared, right? It appears more than once. So what this creates is what's called a repeated solution. The repeated solution of x equals 3. The graph of the related function, what it will do is it touches the x-axis at this point, but does not cross the x-axis at the repeated 0 of x equals 3. So this concept is generalized as follows. When x minus k of f of x is raised to an odd power, so for example, x to the third, x to the first, x to the fifth, if it's raised to an odd power, the graph of f, it crosses the x-axis at x equals k. So for example, if it's odd, then it will cross, just like it does right here. When a factor x minus k of f of x is raised to an even power, so like x squared, x to the fourth, x to the sixth, the graph of f touches the x-axis but does not cross the x-axis at x equals k. So hopefully that reminds you of like our parabolas. Okay, so like an x squared, it bounces or touches at that x-axis. So let's take a look at this example here. So just to kind of tie together what's happening in this chapter, we found the x-intercept at 0 and 3. So we know that it crosses at x equals 0, x equals 3. What else do we know about this? We know that the degree is odd. We also know that the leading coefficient is positive. So what does that mean about our end behavior? Remember with the end behavior, if it's odd, the ends go in opposite direction. So that's one thing we know. Then we also know these x-intercepts. Now one more thing we know is that if it's a repeated 0, so if it's raised to a square or a fourth, then we know that it will bounce off of that x-axis. So because x minus 3, that's repeated, it's going to bounce at this 3. The 0 here, that's 2x here, raised to the first power, that is odd. So that means it's going to cross at x equals 0. So now we can complete this graph. We know that it does something like this, right? So a better sketch. We know where the x-intercepts are. So this is a lot faster than when we graphed at the beginning of the chapter when we plugged in numbers. Now looking at this one, it's to the fourth power. So what do we know about the ends? The ends are the same because it's even. We know the leading coefficient is positive, so which way do the ends open or go? We know that they go up. Our x-intercepts, we know is at negative 1, 1, negative 3, and 3. So negative 1, 1, negative 3, and 3. Nothing's repeated. We also know that our y-intercept is at 36. So let's just sketch it at 36. So here's a little bit more better picture of the graph. We know it crosses at 3, crosses at 1. It crosses the y-axis at 36. -1 crosses through, and -3 crosses through, and it goes up. So we have a better picture of what this graph looks like. So that's what we're going to apply in the next examples.